PSI, WSSC, that's pipe scene investigation and a whole lot more. Greg Fick and Mohammed Tak, part of WSSC's Water Condition Assessment Team.
I oversee all the PCCP inspections and the rehabilitation efforts.
PCCP, pre-stressed concrete cylinder pipe. WSSC has 145 miles of PCCP for water, ranging from 36 to 96 inches in diameter.
And there have been instances where I would have sleepless nights because of emergency and urgent situations going on in the field. But overall, if you look at the program, WSSC is considered industry leader.
In 2007, the Commission implemented a large main condition assessment and monitoring program that now boasts impressive results.
Currently, we monitor about 90 miles of PCCP, 42-inch and greater. We have another 68 miles of 42 and 36-inch mains to go that will pave the way for future monitoring.
Monitoring via acoustic fiber optics, or AFO, a cable installed in our larger PCCP.
And that monitors the pipeline while it's in service and can also hear the acoustic noise of the wire snapping.
Those wires give PCCP its strength. They break and the pipe could fail.
If it gets to a point where we have enough of them snapped and we know what the level is of how much the pipe can take, we do an intervention, which we emergency shut down the main and get in there and fix that pipe before we have a failure.
The effectiveness of this program is that we not only manage the risk, but we have avoided about 12 imminent failures through this program in the last 8 years.
And repaired well over 300 pieces of PCCP that are in various forms of distress. So we're being very successful in keeping all our big PCC transmission mains in good sound working order.
You got this tight?
In addition to monitoring its large mains, WSSC simultaneously runs a rigorous inspection program of those same pipes using the latest technology.
A lot of information you can gain by being inside, touching and looking at it and sounding it with a hammer.
But manned inspections of the big pipes aren't always possible.
We're to provide water to our residents and also provide fire flow. You just can't assume we can shut down a main and then just go in and inspect the pipe. It's a lot of coordination internally.
Let me get a locate at 4
And for the
5.
smaller of the larger big pipes, such as a 36-inch, a variety of robots replace people for inspections.
Pipe diver is a substitution of man entry.
Trying to get through each PCC pipe 36-inch and greater in a 5 to 6 year cycle. And this is the first time this one's ever been inspected.
Armed with electromagnetics, in goes pipe diver to inspect a nearly 2-mile stretch of 63-year-old PCCP that moves water from the reservoir to the Patuxent water filtration plant.
Broken wires sends a magnetic field into the pipe, and then there's a sensor that analyzes that field and it can tell if the wire has separated.
An aquatic robot of sorts, going with the flow, capturing critical data on the health of the pipe.
So basically, because the inspection is done on a pressurized main, we don't have to shut it down, we don't have to disrupt service to the customers or even to the production at the plant, right, which is treating the water.
This is the most advanced state-of-the-art that anywhere in the world, and it's been very successful for us in detecting distressed pieces of PCCP pipe that we can individually go down and either dig on them and replace them with a metal piece of pipe, or if we can't dig on them, we can drain the pipe and get inside and wrap it with carbon fiber, and that reinforces it.
Okay, Daniel, we've reached the end point at 4740 feet.
Before closing the case on this inspection, the team must also check for leaks. Sometimes they deploy a smart ball to locate leaks, but today it's a different tool that captures video and helps look for leaks.
This technology is called Sahara.
It records leaks and gas pockets, so it's all acoustic based.
We insert a parachute into the main, and the flow of the water is captured by the parachute, and the parachute drags an acoustic sensor along with it in the flow. And that acoustic sensor is listening for the hissing sound, the sss of a leak. And it can pinpoint exactly where it is because we have people following the sensor above ground.
We can put an X on the ground and you can be repairing that leak or marking that location immediately. There's no waiting for analysis It's real-time leak location.
And in this case, no leaks detected. The team will further investigate some pipe sections for possible repairs. Then it's on to the next stretch of PCCP because
These mains are critical for supplying water to WSSC customers, and we have to do everything we can to maintain them at their best.